So in the next section, 1.3, we're going to talk about reference angles. So in the last section, we talked about a coterminal angle. Now we have another type of angle in relationship to an angle measure, and that's called reference angles. For any angle theta in standard position, the reference angle is the positive acute. Remember from geometry, acute means the angle has to be less than 90 degrees, or in radians less than pi over 2. So it has to be a positive acute angle formed by the terminal side of the angle and the positive x-axis, the positive or the negative x-axis. So it can be with the positive or the negative x-axis. So for example, if you have an angle whose terminal side is in quadrant 1, your reference angle I'm referring to as theta prime. So again, I'm referring to that reference angle as theta prime. Theta is that original angle that's given to me. So in quadrant 1, if this angle is already an angle measurement between 0 and 90 degrees, or 0 and pi over 2, theta will be its own reference angle. Because remember, the reference angle is the angle that's formed between the terminal side and the x-axis. So your reference angle is the same as the original angle, given that theta is between 0 degrees and 90 degrees, or 0 and 2 pi. So now the difference is what happens if your terminal side is now in quadrant 2. Clearly this is going to be an obtuse angle because the angle measurement is greater than 90 degrees. Your reference angle, again, it's formed between the terminal side and the positive or negative x-axis. So right here is your reference angle. That's what you're trying to find. This is your reference angle. So then to find your reference angle, what I'm going to do is I know that if I make a rotation all the way over to the negative x-axis, that's going to be 180 degrees. So to find my reference angle, what I'm going to do is I'm going to take 180 degrees and subtract from it theta. Or in radians, it would be pi minus theta. Again, because you're trying to find this angle that I've highlighted here in yellow. Now, if you're down here in quadrant 3, again, we know that this is clearly an obtuse angle. It's greater than 90 degrees or greater than pi over 2. So the reference angle, again, it's always between the terminal side and the positive or negative x-axis. So right here is my reference angle. So to find my reference angle, this is the angle measurement that I'm trying to find. So I know that when I go over here to the negative x-axis, that's 180 degrees. But then I have to go an additional degrees to get down here to the full theta. So then to find theta prime, to find the reference angle, what I'm going to do is I'm going to take theta and I'm going to subtract out that 180 degrees to calculate what this highlighted region is. Or in radians, it would be theta minus pi. In quadrant 4, again, the reference angle is always formed between the terminal side and the positive or negative x-axis. Remember, reference angles are always positive and they're acute. So right here is the reference angle that I'm trying to find. Again, I know if I make one complete revolution, that's 2 pi or 360 degrees. So to find my reference angle, what I'm going to do is I'm going to take 360 degrees and subtract the angle out. That would calculate that highlighted region for me. Or in radians, it's going to be 2 pi minus theta. So this is the illustration. When you're trying to find a reference angle, it depends upon, first of all, the idea is the easiest way to do this is to get your angles between 0 and 90 and 0 and 2 pi. So that's where you could find the coterminal angle between 0 and 90 and 0 and 2 pi. Then you can use these calculations to help you calculate the reference angle. So here is 7 pi over 3. So that we sketch theta and find its reference angle. And like I just mentioned, if the angle is not between 0 and 2 pi, find the coterminal angle that is between 0 and 2 pi first. So I know 7 pi over 3, remember 2 pi is equivalent with a common denominator of 3 of 6 pi over 3. So I know that 7 pi over 3 is greater than 6 pi over 3. So what I want to do is find my positive coterminal angle first between 0 and 2 pi. So I'm going to take 7 pi over 3 minus 6 pi over 3, which gives me pi over 3. So again, when I sketch 7 pi over 3, I know it's going to be one complete revolution around, and then pi over 3 is located right here in quadrant 1. So my reference angle then is going to be the same as that positive coterminal angle that I found, since that terminal side is already located in quadrant 1. So my reference angle is going to be pi over 3. And again, when I sketch 7 pi over 3, it's going to be one complete revolution around. And again, what you found with this pi over 3, you have found this region right in here, what I highlighted in pink. So 17 pi over 6. So in radians, if you look at 2 pi with a denominator of 6, that's equivalent to 12 pi over 6. So I know that 17 pi over 6 is greater than 12 pi over 6. So the first thing I want to do is I want to find the positive coterminal angle first that's between 0 and 2 pi. So I'm going to take 17 pi over 6, and I'm going to subtract the 12 pi over 6. So that's going to give me 5 pi over 6. So what I want to do is I want to sketch 5 pi over 6. When you're trying to do reference angles, you really always want to get a picture. You always want to sketch the angles. So 5 pi over 6 is going to have that terminal side located over here in quadrant 2. So there's 5 pi over 6. Remember, the reference angle is the distance between the terminal side and the positive or negative x-axis. So this is the region that I'm trying to find. Remember, if you have that angle in quadrant 2, what you want to do back to the previous page, I know that if I go all the way over to the negative side of the x-axis, that's pi. So then my reference angle is going to be found by taking pi minus that 5 pi over 6. And again, I know that pi is equivalent to 6 pi over 6 minus 5 pi over 6. So my reference angle is going to be pi over 6. So again, that's the measurement that I just found that I highlighted in yellow. So again, the key is if the angle that you're trying to find the reference angle for is not between 0 and 2 pi, find that positive coterminal angle between 0 and 2 pi first. And I know that 17 pi over 6, if I was to sketch that angle, I know I would have to make one complete revolution around and then go another 5 pi over 6. So that's the angle of 17 pi over 6. 6 pi over 5. 6 pi over 5 is already an angle measurement that's between 0 and 2 pi. If we know that this is pi, pi I know is equivalent with a fraction with a denominator of 5 is the same as 5 pi over 5. So 6 pi over 5 is going to be down here in quadrant 3. And again, my reference angle, it's the distance between the terminal side and the positive or negative x-axis. So this is the region that I'm trying to calculate, the distance. I'm trying to calculate this angle that I've highlighted in yellow. So remember, when you have an angle that's in quadrant 3, to find your reference angle, you're going to take your angle measurement of 6 pi over 5, and you're going to subtract pi, which in this case is equivalent to 5 pi over 5. So 6 pi over 5 minus 5 pi over 5 is just going to give me pi over 5. So again, that's that region that I highlighted in yellow right there. 1.75 pi. Again, 1.75 pi. Again, if you feel better and you want to convert this into a fraction, I know that 1.75 is equivalent to 1 3/4. So 1 3/4 is equivalent to 7 pi over 4, or 7/4. So 1.75 pi is equivalent to 7 pi over 4. So if I sketch 7 pi over 4, well, I know that 2 pi is equivalent to 8 pi over 4. So I know that 7 pi over 4 is an angle measurement that's already less than 2 pi. So the terminal side for 7 pi over 4 is located down here in quadrant 4. So there's my 7 pi over 4. Again, I'm trying to calculate the distance between my terminal side and the positive x-axis in this particular case. So when you have an angle whose terminal side is in quadrant 4, again, remember, if I make one complete revolution around, that's going to be 2 pi or 360 degrees. So to find my reference angle, I'm going to take 2 pi and subtract 7 pi over 4. And again, I know with a common denominator, 2 pi is going to be equivalent to 8 pi over 4. So my reference angle is going to be pi over 4. So when you look at the next example, negative 3 pi over 4, negative 3 pi over 4, notice I know it's not a positive angle between 0 and 2 pi. So the first thing I want to do is I want to find my positive coterminal angle between 0 and 2 pi. So what I'm going to do is I'm going to take negative 3 pi over 4 and I'm going to add 2 pi to it. Again, I know with a common denominator, 2 pi is equivalent to 8 pi over 4. So negative 3 pi over 4 plus 8 pi over 4 is going to give me 5 pi over 4. So negative 3 pi over 4 and 5 pi over 4 share the same initial and terminal sides. So there's my initial side. 5 pi over 4 is located down here in quadrant 3. Again, the reference angle, it's that distance between the x-axis and the terminal side. So remember, when you're trying to calculate a reference angle whose terminal side is in quadrant 3, what you're going to do is you're going to take your angle and you're going to subtract out pi. And again, I know pi is equivalent to 4 pi over 4. So 5 pi over 4 minus 4 pi over 4 is going to give me pi over 4. So again, that's that reference angle right in here. Again, if I needed to sketch negative 3 pi over 4, remember negative 3 pi over 4 is the angle measurement rotating in that clockwise direction. Negative pi over 7. So again, I know that negative pi over 7 is indeed not a positive angle between 0 and 2 pi. So to find the positive coterminal angle, I'm simply going to take negative pi over 7 and add 2 pi to it. So negative pi over 7 plus 2 pi, again, remember 2 pi is a common denominator of 7 is equivalent to 14 pi over 7. That's going to give me 13 pi over 7. So some of you probably have already seen that negative pi over 7 has to have that terminal side down there in quadrant 4. My reference angle is that distance between the x-axis, the positive x-axis and the terminal side. Again, here's 13 pi over 7. Here's negative pi over 7. So some of you can probably already see that the reference angle is just the absolute value of negative pi over 7, which is pi over 7. Or, since you have your 13 pi over 7, that's your positive coterminal angle between 0 and 2 pi, you can simply take your 2 pi and subtract 13 pi over 7 from it. So there's my reference angle. So there's your reference angles.